Hey guys, welcome to my video demonstrating the Proton Z80 Modular Computer. So this is the beauty or the beast. It's a rack. This rack has 9 slots. Here we are using 8 of the slots. And let's see each card, what they are. Starting with this one. Take out the power cord. This is the PSU, which is the power supply unit. So this card provides the 5 volts for all the other cards. Besides that, it provides also 12 volts and 3.3 volts. These other 2 voltages can be selected here, enabled or disabled here. So if you don't need 12 or 3.3 volts, you just take out the jumper and no voltage. On the front we have the switch and the mains connector, the 3 LEDs that indicate the 3 voltages, if they are enabled or not, and a small connector here. It's a 2-pin connector that externally, with a 5 volt signal, you can turn on the power supply. So let's say, for example, you have a modem or something like that. So you can turn on the power supply without using the switch. Let's go ahead. The next card is the CPU card. So the CPU has the Z80 CPU, the clock circuit, and the power on reset circuit. On the front we can see here that we have a reset button and also 2 LEDs, one that indicates power on and the other one that indicates that the CPU is in a halted state. Next card is the memory card. So this card has the EEPROM, has also the RAM and some auxiliary circuits. The EEPROM is inserted in a ZIF socket, so you can easily take it out, reprogram it, and put it back. The 64 KB of the EEPROM is divided in 4 blocks, 0, 1, 2, or 3. So according to which one of these jumpers you select, from which of the blocks the system will boot. On the front we have the 2 LEDs to indicate which is the selected block. There's another LED that indicates that the ROM is active or is being used. And the bottom LED indicates which one of the banks of RAM is being used, because the RAM is 128 kilobytes RAM. So you can use bank 0 or bank 1. It can be selected in 2 ways. This selector here, this connector here has a jumper, so you can select from the jumper with bank 0, bank 1, or if you put it in the middle, it will be software selected. Next card is the flash card. So the flash card emulates the disks. It has this adapter here that converts from a 44-pin IDE to the flash card. You can see that the compact flash is 128 megabytes. It's an industrial type. On the front, the only thing that we can use here is there is a built-in LED on the adapter that shows the compact flash activity. It's somewhere here on the top. Okay, Moving ahead, the next one is the TTY. This card has 2 serial ports, and each port is controlled by an independent microcontroller. In this case, I'm using, for each one, I'm using an Atmel ATmega 328. And as I said, they are completely independent, and they can provide RS-232 signal or TTL level signal, which is selected by these jumpers. On the front, you can see here we have the DB9 connect for TTY0. There was no space to put a DB9 for the TTY1, so only TTY0 uses a DB9 for the RS-232. And in the middle, there's another small 4-pin connector that provides the TTL level for TTY0. And then on the bottom, you see there's a 6-pin connector, which provides both RS-232 level and TTL level for TTY1. The LEDs indicate TX and RX for each one of the ports. Next one is the I2C. So this card is, as the name says, it provides an easy way for the microprocessor to interface with I2C devices. And this is done using a microcontroller. This guy here, this is also an Atmel, but this is AT89C 4051. So it interfaces with the CPU, the Z80 CPU in a high level, and does all the dirty job about the I2C protocol. And on the board we have here a real-time clock, and also this is a EEPROM. I think it's a 8K EEPROM, and this battery keeps the power for the oscillator when the card is not being powered, so we don't lose the time, real time. And this area here is for prototyping. You can put other ICs here, connect to the I2C bus. And also on the front there's a connector here that can be used to connect to external I2C devices. Let's say, for example, a LCD. Okay, let's check this guy. This is the PX051. What is it? Well, as I said before, the I2C card uses a microcontroller, the AT89C 4051, and it has to be programmed. So this guy is the programmer for the microcontroller. It has a PPI here, 8255. And on the front here we have a ZIF socket to put the microcontroller that we want to program. Last but not least, we have this guy here, that is the LCD. It has a 2x16 LCD. It's called just LCD. And very simple card, just interfaces. It's also wire rapid, and it connects to this card, that is the extension card, and this card connects to the back plane. So it doesn't go inside the rack, but it stays outside. So for example, if you want to do some debugging or troubleshooting, you can connect your oscilloscope here and measure some things. Each card has a specific address. It's a 16-bit address, and it's selectable via a connector. Each card has its own connector, 4 bits. So the cards are inserted in the rack. You can see that the rack is also modular. In this case, the rack has 3 back planes, 1, 2, and 3, that are interconnected. And theoretically, we can put more. We can put 4 or 5 back planes, so we can expand the capacity. I never tried with more than that. I tried with 4. It works perfectly. Maybe with 5, it will have too much noise, but maybe I'll try that. So as I said, we have the slots here. The cards are inserted here, so we can put 9 cards at all. I still have 1 slot remaining for some other experience. Okay, so now let's put the cards back and run something and check how this works. Okay, so now that you've seen the outside, the static part of the Proton, let's see how it works. So first of all, this is the terminal emulator. It's called Term. Very interesting. I would say that is the best terminal emulator that I found to use with the Proton. Here, let's see the setup. Serial port, COM5, so we're running at 250K BPS. That's a huge speed. 8 bits, non-parity, 1 stop bit, no flow control. So now let's turn on the computer. As you can see here, we have an initial message from the TTY card. And then we have the initial message from CPM. Okay, we're on drive A. So let's see what we got here. I'd rather use the D command. Now we can see it in alphabetic order. We have here basically some utilities for CPM. Let's start with a demonstration about this screen. Wow, that was fast. Okay, let's clear this. And now let's do something different. Let's change the serial port speed. To do that, we use this program here. So we're going to select C0, and now let's run at 9.6K. Yes. And now we come here and change the configuration and put here 9.6. Okay. And now we're back. Let's run again the screen test, see what happens now. Wow. Awful. Let's go back to 250K. And we're back. Now let's do something else. This is a small program. Oops. Small program I wrote. So, does it remember something? Cool, isn't it? Okay, another thing that I want to test here and show you guys is the xmode. So let's say that I want to transfer a file from my computer to the Proton. So I would do like this. Let's put it in drive P. The name doesn't matter. Receive. And now we come here, File, Transfer, xmode, and Send. Let's say that we're going to send this guy. So as you can see, we're transferring this file, and it's quite big. I think it has something like almost 300K. We have a byte transfer counter there, and you can see that our speed is 7.8 KB per second. This is also limited by the Windows 10. I made the same test using version 8 or 7, and I got 11 KB per second. Okay, so file received. If I check what I have here on drive P, now as you can see, 320K received. That was great. Okay, so let's go now to drive B. Let's see what we have here. This is the B basic disk. So here we have Microsoft Basic Compiler, BASCOM, and also the interpreted version, that is MBasic. And here you are, let's say 10, and below. No, this is not going to work. Let's try again. Okay. That was good. Not exactly what I wanted, but it was good. Okay, so let's get out. Okay, let's go to drive C. And here what we have in drive C, it's the C drive or C disk. Here I have the BDSC compiler, linker, and a few programs that I made. Let's see, for example, how we run it. So, compiling. Now, oops. Okay, now let's run it. This is a small program that I've made to use the RTC real-time clock on the I2C card. So if I put here T question mark, I get the time. If I put D question mark, I get the date. If I just put a Q, I exit. Now let's see another demo on C. Let's put 0 delay. And this is emulating stars in the sky. Yeah, that's the best you can do using a serial terminal. That's okay. So abort. Clear the screen. And now let's go ahead. Now drive B. This is the disk that contains the assembler and assembly files. Here I'm talking about the SLR Z80 assembler. So here we can test, for example, let's say Z80. Now let's run it. Perfect. Let's go ahead. This is drive E. What we have here is WordStar. So Let's see how it looks. Cool. So let's open something. For example, this is the clock program that we've seen before, and this is the program. Quite neat. Okay, now let's go to drive F. What do we have here? Oh, this is the fourth. So here we have F83. F83. And welcome to the fourth. I don't remember much about the fourth. So let's say bye. And now we're back again. Let's go to drive G. What do we have here? Oh, this is a SuperCalc. It's a spreadsheet. Very, very, very nice. So let's run it. Okay, let's load something. Control V. So let's load this guy. And here we have. This is a spreadsheet. It's a balance. Very nice also. Quit. Yes. Now let's go to drive H. What we have here is dbase. Okay. Blah 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 blah. I don't have anything that I've done here in the dbase, so no demonstration. Let's just quit. And that's it. Thank you for watching this video.